Hello and welcome to Exponentially Advanced, where we start small and we get bigger. Okay? So today we're doing solving systems of equations by substitution, where we will have infinitely many solutions, one solution, or no solution. So for today, we're using substitution. And so we're going to start off with our first problem. You can pause the video and try to solve a problem yourself, or you can just go along with me. So when we need to substitute, we need to have a variable isolated. I've done a nice thing for y'all, and I already isolated the variable. Okay, so in our first equation, y is already isolated. And in the second equation, we need to replace y with 3x minus 11. So when we hear substitution, we hear, what comes to me is replace. So I'm going to replace y with 3x minus 11 in the second equation. Okay, so just like this, 3x minus 11 minus 3x is equal to negative 13. Okay, so because there is nothing outside the parentheses that needs to be distributed, we can go ahead and remove it. So we will have 3x minus 11 minus 3x equal negative 13. Now, 3x minus 3x becomes 0 because they're saying $3. You lose $3, you got no dollars, okay? So we have negative 11 is equal to negative 13. We all know that is no way near true, okay? $11 and $13 nowhere near true, nowhere near equal. So that basically tells us we have no solution, okay? So with that being said, a little bit background knowledge is if they have the same slope, that means they're parallel lines, which also means they have no solution, meaning they do not intersect whatsoever. So if you take the first equation, you have y is equal to 3x minus 11. But if you was to rearrange the second equation, you get y is equal to 3x minus 13. They may have different intercepts, but they have the same slope. Okay, 3x, okay? They have the same slope, which is 3. Therefore, that means that they are parallel lines. Okay, aka same slope. And you can use Desmos to graph them, and it'll show you how that neither one of those two intersect with each other, okay? So, no solution is your answer. Onward to our second one. Same way, same rule, same procedure. Y is isolated, and so if I see y, I'm going to replace it with x plus 3. Okay? So we get 3x plus 4 times x plus 3 is equal to 7. Okay? So I replace y, because remember it was 4y. So I replace it with x plus 3. Now I'm going to distribute this 4 into everything inside the parentheses. That's why I have 3x plus 4x plus 12 is equal to 7. Now, that gives me 7x because 3 plus 4 is 7. Your x's are together, so you just bring them together. Plus 12 is equal to 7. Subtract 12 from both sides. And so you will have 7x is equal to, negative 5. And so you divide both sides by 7. And that's your value for x. So x is equal to negative 5 over 7. Now, when you have a value for x, it doesn't matter which one you plug it into to find your value for y. But I always tell my students, always plug it into the simplest one, the one that already has a variable isolated because it's less work that you have to do. So, you simply going to take this beautiful, and you're going to plug it into this one. Okay? So you have negative 5 over 7 plus 3 is equal to y. And you know 3 over 1 is the same as saying 3. So it really don't matter. So we need to know the least common multiple of 1 and 7. Basically, what number does 1 and 7 have in common? 7. So whatever we do to the bottom, we do it to the top. So we have negative 5 plus 21 over 7 is equal to y. Okay? So 21 minus 5 is 16. So you have 16 over 7. So your pair is negative 5 over 7 and 16 over 7. So this means you have one solution. That means where these two lines intersect, that's where they'll intersect. When you graph both of the equations, this is where they will intersect. Okay? You would just have to transform this equation right there from standard form into slope-intercept form to find out where they intersect. Or you can just do substitution. Okay? So on to our last one. Same procedure. You can see if you can get done before I can. You probably will, though, because I'm teaching. So we take 3.5. Remember, because x is isolated, we're going to substitute negative 2y plus 4. Okay? So negative 2y plus 4 plus 7y is equal to 14. So now we're going to distribute this 3.5 inside the parentheses, which give us negative 7y plus 14 plus 7y is equal to 14. Now, negative 7y plus 7y gives us 0. You have $7, you lose $7, you have $0. So we got 14 is equal to 14. This statement holds true because 14 is equal to 14. And so if your solution is like this, it means you have infinitely many solutions. Which also means you have one line. Both of these are one line. These are the same lines. Okay, that means these are the same line. Okay? That means they just meet on each other in every single point. It's going to be the same for y. Okay? So, hope you enjoyed the video. You can like, comment, and subscribe if you have any questions, comments, or concerns about the video or any problems. And you find any videos that you want, any problems that you want me to do, just leave them in the comment section.